What they didn't teach you at school about Andromeda. Okay, I need to tell you something, and I need you to stay with me here because this is important. Everything you were taught in school about the Andromeda Galaxy, our closest galactic neighbor, is either incomplete or flat out wrong. And I don't say that to be dramatic. I say that because on January 16, 2025, the Hubble Space Telescope released an image so detailed, so staggeringly vast, that it is rewriting what we thought we knew about the galaxy next door. An image containing 200 million individually resolved stars. 200 million. Let me say that again so it lands properly. 200 million stars, each one visible, each one cataloged, each one telling a story that your science teacher never had access to. And what that image revealed is not a peaceful spiral drifting quietly through the cosmos. What it revealed is a galaxy with a violent, turbulent, and frankly terrifying history. A history of collisions, of galaxies being ripped apart and consumed. And here's the part that should make every single one of us sit up and pay attention. That violence may not be over because Andromeda may be coming for us next. Here's what you need to understand. What I'm about to walk you through tonight isn't speculation. It's not science fiction. This is based on direct observational data from one of the most powerful telescopes ever built, backed by peer-reviewed research and numerical simulations. And by the time we're done, you're going to look up at the night sky very differently. If this is your first time here, subscribe to this channel right now and turn on notifications because we don't just skim the surface on this channel, we go deep. We connect the dots, and when it comes to what's happening in our universe, you deserve to know the full story. So let's start at the beginning, and I mean the very beginning. Humans have been staring at Andromeda for more than 1,000 years. The first recorded observation was in 964 AD by a Persian astronomer named Abd al-Rahman al-Sufi. And you know what he called it? A nebulous smear. That's it, a fuzzy patch in the night sky. And for nearly 700 years, that's all anyone thought it was. Then in 1612, a man named Simon Marius became the first person to point a telescope at that smear. And what he saw was still fuzzy, still unclear, but it was something. Over the next few centuries, astronomers kept poking at it. Charles Messier gave it the official designation M31 in 1764. And then came a man with an enormous telescope and an even bigger ambition. William Parsons, the third Earl of Ross, built a 72-inch telescope in the garden of his castle in Ireland, 72 in. It was called the Leviathan of Parsons Town, and it remained the largest telescope in the world for 70 years. Parsons used that beast to discover spiral structure in a nebula called M51, the Whirlpool Galaxy. That was the first time anyone had ever seen spiral arms in a celestial object. And that discovery lit a fire under the entire astronomical community. In 1888, an amateur British astronomer named Isaac Roberts took the first ever photograph of Andromeda. And right there in the photograph, clear as day, spiral structure. But even with photographic evidence, scientists still weren't sure what they were looking at. Was it a cloud of gas inside our own Milky Way, or was it something else entirely? Something out there beyond the boundaries of everything we knew. Stay with me here, because this is where the story takes a turn that changed our understanding of the entire universe. In 1925, Edwin Hubble, yes, the man the telescope is named after, found two special stars inside Andromeda called Cepheid variables. These are what astronomers call standard candles. Their brightness pulses in a predictable way that lets you calculate how far away they are. When Hubble did the math, he got a number that stunned the scientific world. These stars were approximately 1 million light years away, far too distant to be inside our galaxy, which at the time was thought to be no more than 300,000 light years across. Think about what that means. In one calculation, Edwin Hubble proved that Andromeda was not a nebula inside the Milky Way. It was an entirely separate galaxy. And with that single realization, the universe went from being one galaxy to being unimaginably vast. Overnight, everything got bigger. Now here's where your school textbook probably stopped. They told you Andromeda is a spiral galaxy about 2.5 million light years away. Maybe they mentioned it's the closest major galaxy to ours. Maybe they showed you a nice photograph, but what they didn't tell you is what Hubble has spent the last 10 years uncovering. And what it found is extraordinary. Here's why that matters. Studying galactic structure from inside the Milky Way is extremely difficult. We're inside the thing. Interstellar dust scatters light. Distances are hard to measure, and foreground noise blocks critical details. It's like trying to read a map while you're standing on it in the middle of a rainstorm. But Andromeda, sitting 2.5 million light years away, gives us a clean, relatively unobstructed view of how a galaxy actually works. It's our laboratory, our test case. And now, thanks to Hubble, we have the clearest picture of that laboratory ever produced. The image is a photomosaic assembled over 10 painstaking years. It was constructed from more than 600 individual snapshots taken across over 1,000 Hubble orbits. The final result contains 2.5 billion pixels. To display it at full resolution, you would need 75 8K ultra-high-definition screens, 75. And within that image, 200 million individual stars, each one resolved and cataloged. The Hubble team described the density of stars as looking like grains of sand on a beach. That's not poetic license. That's a literal description of what you see when you zoom in. If you're finding this as fascinating as I think you are, hit that like button right now, because this story is about to get significantly more complicated and significantly more violent. Because when scientists started analyzing this image in detail, they found something that textbooks never prepared them for: rings. Two concentric rings of dust and star formation that had no business being there in a normal, undisturbed spiral galaxy. The first ring was spotted in the outer region, roughly 10 kiloparacs from Andromeda's center. It's an elliptical ring packed with newborn stars, bluer and hotter than most others in that region. These young stars are also metal-rich, meaning they contain heavy elements forged in previous generations of stellar explosions. The second ring was found much closer to the center, about 0.5 kiloparsec out. It was discovered using infrared data from the Hubble Space Telescope back in 2006. Scientists had initially thought it was just a mini spiral, a dense region of overlapping stellar orbits. But when they looked more carefully, they realized it was a ring too. Two rings. And here's the thing, rings like these don't just appear on their own, as astronomer David Bloch put it. And I want you to hear this exact phrase because it tells you everything. These dust rings are like ripples in a pond. And where do ripples come from? A point of impact. That's right. Scientists concluded that both rings are the remnants of a head-on collision between Andromeda and one of its smaller companion galaxies approximately 210 million years ago. Just like dropping a stone into still water, the impact sent shockwaves of dust and gas radiating outward through Andromeda's disk, leaving behind two ghostly trails that we can still detect today. The prime suspect, a dwarf galaxy called Messier 32 or M32. Today, M32 appears as a bright, fuzzy smudge of stars, sitting just 5 kiloparacs from Andromeda's center. When researchers ran numerical simulations of the collision, they were able to reproduce both rings, including a conspicuous gap in the outer ring where it interlaced with one of Andromeda's spiral arms. The simulations matched the observations almost perfectly. Now, stay with me here because this distinction matters enormously. For decades, scientists looked at Andromeda and saw a relatively peaceful galaxy, a big spiral. Sure, a dominant force in the local group. Absolutely, but not a violent one. Those rings changed everything. They proved that Andromeda has a history of consuming other galaxies. But the 2006 discovery was just the beginning because the new Hubble image revealed that Andromeda's violence goes far deeper than anyone imagined. You see, the complete image wasn't finished until recently. The original survey called PHAT, the Panchromatic Hubble Andromeda Treasury, ran from 2012 to 2015 and photographed the northern third of Andromeda's star-forming disk across 6 spectral bands. But astronomers noticed something troubling. The southern region of the galaxy looked fundamentally different from the north. It was far more disturbed, more chaotic, more scarred. So they launched a second survey called FAST, extending the program to cover Andromeda's southern region from February 22, 2026. FAST added another 90 million stars to the census and expanded coverage to 2/3 of the galaxy's star-forming disk. And what they found in the south was devastating evidence of an even larger ancient collision. There is a structure called the Giant Southern Stream, a mammoth trail of stellar debris stretching roughly 150 kiloparacs from Andromeda's southern disk out into the halo. Think of it as the ghostly remains of a galaxy that was torn apart, its stars stripped away one by Andromeda's overwhelming gravity. The stars in this stream are cold. They hold no significant gas. They don't collide with each other. They just drift like marbles rolling down separate frictionless tracks, still following the gravitational paths carved out by an ancient catastrophe. Here's where it gets genuinely terrifying. The giant southern stream M32 and the inner halo all share something in common. They're all unusually metal-rich. For astronomers, that shared metallicity is a smoking gun. It suggests all three features are products of the same event, a collision far more massive than the one that produced the rings. And the prime suspect once again is M32, or rather what M32 used to be. A landmark study in 2018 used cosmological simulations to reconstruct what happened. They concluded that the galaxy responsible for all this destruction was an earlier, much larger version of M32, which they named M32P. In its prime, M32P had a mass of 25 billion suns, and between 2 and 5 billion years ago, it slammed directly into Andromeda. Let that sink in. A galaxy with a mass of 25 billion suns collided with Andromeda. And the evidence suggests that collision created roughly 1/5 of all the stars we see in Andromeda today. 1/5. That's billions of stars that exist because of a single act of galactic violence. And what happened to M32P? Its gas was stripped away by Andromeda's gravity, triggering a burst of star formation. Its outer stars were scattered into streams and halos, and its core, its dense, compact nucleus, survived. That surviving core is what we now call M32, the bright little smudge sitting on Andromeda's doorstep. It's not a small independent galaxy. It's the beaten, stripped-down remnant of a once massive galactic giant that Andromeda consumed billions of years ago. Now, I need you to hold all of that in your mind because here's the question that really matters. Is Andromeda done? The answer, based on current research, is almost certainly no. Andromeda has 36 known dwarf galaxies surrounding it. Any one of them could interact with it in ways we haven't yet detected. And now, for the first time, we have an image detailed enough to start looking for the evidence of those smaller-scale interactions. Scientists are just beginning to mine this data. Who knows what additional collisions, mergers, and disruptions are hiding in those 200 million stars? But the collision that concerns us most isn't in the past, it's in the future. Andromeda and the Milky Way are the two largest gravitationally bound galaxies in our local group. And for years, the prevailing scientific consensus has been that they are on a collision course. A 2012 study estimated that Andromeda is falling toward us at a speed of 110 km/s, and that the two galaxies will merge in approximately 4 billion years, forming a new combined galaxy that some astronomers have already nicknamed Milkomeda. Think about what that means for a moment. Our home galaxy, everything we know, every star we've ever seen in our night sky, is potentially headed for a direct collision with a galaxy that has already demonstrated conclusively that it devours other galaxies for breakfast. But here's where this story takes one final unexpected turn. And this is something that was only possible because of the new Hubble data. In a paper published recently, researcher Till Sawala from the University of Helsinki and his colleagues used the PAT survey data to refine models of the local group's gravitational dynamics. Specifically, Hubble measured precise distances to 55 Cepheid variable stars within Andromeda. Those measurements, combined with updated orbital data from other local group galaxies like the Large Magellanic Cloud, produced a revised prediction. And the result? The chance of a merger between Andromeda and the Milky Way in the next 10 billion years is now estimated at roughly 50%. Not a certainty, a coin flip. So either our galaxy is going to be consumed in one of the most spectacular events in cosmic history, or it's going to narrowly avoid destruction by the most violent galaxy in our neighborhood. And right now, we genuinely don't know which one it will be. Drop a comment right now and tell me which outcome you think is more likely. And tell me where you're watching from. I want to know how far this is reaching. Let me leave you with 3 things. 1. The Andromeda Galaxy is not the peaceful spiral your textbook showed you. It is a galactic predator with a confirmed history of devouring other galaxies, including one with a mass of 25 billion suns. 2. The Hubble Space Telescope has just produced the most detailed image ever taken of any galaxy in the universe, resolving 200 million individual stars and revealing evidence of multiple catastrophic collisions spanning billions of years. 3. Whether or not Andromeda collides with our Milky Way is no longer a settled question. The latest data gives it a 50-50 chance over the next 10 billion years. The universe hasn't made up its mind yet. The 10-year effort of the FAT and FAST programs may be complete, but scientists are nowhere near done analyzing what they found. There are secrets buried in those 200 million stars that we haven't even begun to uncover. And in June of this year, the Chandra X-ray Observatory released new images of Andromeda's supermassive black hole in unprecedented detail. Each observation adds another piece to a puzzle that spans billions of years and millions of light years. We are living in an extraordinary time for understanding the universe around us. The tools are more powerful than ever. The images are more detailed than ever. And the stories they're telling us are more astonishing than anything we could have imagined when Abd al-Rahman al-Sufi first looked up and saw a nebulous smear more than 1,000 years ago. The cosmos doesn't care whether we're paying attention, but we should be, because what's happening out there, what has already happened and what may yet happen, is nothing short of magnificent. Make sure you're subscribed with notifications turned on, because we are just getting started with this story. I'll be watching the skies, and so should you.